Welcome back, everyone, to McCall Science Enrichment, and today's experiment is entitled Purple Cabbage pH. And here are the materials that we'll need to do this experiment. The star attraction today, the key ingredient for today's experiment, is a small-sized head of purple cabbage. This is the cabbage as I bought it from the grocery store. I have some kind of loose outer layers here. You can see where the cabbage was sliced from the cabbage plant when it was harvested, and it's small enough where I can pick it up with one hand, but I tend to have large hands. You don't need a big head of cabbage for this experiment, just a small one will do. You will need today a strainer of some kind that can hold quite a bit of material. You will need some kind of a measuring cup with a pouring spout. That's quite important. You will need today a spoon, our good old spoon. You will need probably at least 2 clear glasses. I'm going to be using, for the most part, short glasses, and as long as you can see inside, it won't matter if they're plastic or glass, that's perfectly fine. And then you need these following 4 key ingredients. Today we'll be using bottled lemon juice. It's not nearly as good as the fresh squeezed stuff, but for today's experiment, it will not matter if you use fresh lemon juice or bottled. Bottled is perfectly fine. You will need some white vinegar. There we go, our good friend, the ever-present white vinegar. You will need probably about 4 teaspoons of baking soda. This is a solid white powder that came from the refrigerator. And then our last ingredient today is the infamous ammonia. Please be careful working with ammonia inside the house. The fumes from ammonia can be quite dangerous, and they can actually destroy and burn. Just the fumes can burn the inside of your nose, so please be careful. And the final dangerous ingredient today that you will need will be a blender. And this is the bottom part of the blender. This is the part where we put our ingredients. We're going to be putting our cabbage pieces here into the blender today, so these rather sharp blades at the bottom can chop up that cabbage and make sort of like a purple cabbage soup. You'll need some water, so you need enough water to cover as much cabbage as putting in here. I'll probably be using about half of my cabbage today, and I'll show you that in a bit. So those are the materials, and now let's move on to our procedures. Hang on. So the first steps for today's experiment focus mainly on the head of cabbage, the blender, and the water inside the blender. Now, I took the liberty of removing those loose sort of outer leaves of the cabbage. They're really colorful on the inside. Here's the inside view, here's the outside view. I'm not planning on eating any of this cabbage, so I didn't bother to wash them or check for bugs or dirt or any of that kind of stuff. I'm just gonna harvest these leaves as they are. I'm not gonna throw them away because they're very valuable, and they have exactly what we need for today's experiment. So as an example, I'm going to take all these leaves, and cabbage is a very fibrous vegetable. It's sort of tough to grind down because it takes a good bit of strength to rip this stuff apart. So I'm going to, in just a second, rip these leaves up into small pieces and just put them inside our blender, and we're all set to go. Now, if you've never seen the inside of a head of purple cabbage, that is an amazing thing too. I sliced this cabbage in half, and you can see that there's air pockets inside the cabbage. I don't know what would happen if you threw a head of cabbage in a tub of cold water, but my guess is it would probably float because there are air pockets here in this cabbage. This is the smaller half of the cabbage, and this would be the bigger half of the cabbage. Again, if I have any kind of strands or pieces on here, I can put those right in the blender and they'll be fine. So what I'm going to do now is I'm going to take probably my bigger half of the cabbage. I'm going to use my fingers to pull those layers apart. I'm going to grab them and sort of tear them into bits, and I'll put those here in my blender. And when I'm done with that, I'm going to turn that blender on and grind up that cabbage as much as possible to make a bright purple soup. So the next scene, you'll see our blender here with bright purple soup. Hang on. So I started off blenderizing my chopped cabbage on a slow kind of a pulse. And then once it got fine enough, I went to a very, very high speed, and I had to watch myself because it was going so well. I kept letting it run and run. I thought, boy, that's awfully pretty. And then I realized that if my cabbage in this container gets to be too small, it's going to fall through my little wire mesh sieve here, which is bad because I really don't want to get cabbage chunks in our juice. I just want the purple juice and not the pieces of cabbage. So I had to stop myself in time so that I didn't get too many small pieces in here. So all I'm going to really do now is pour enough of this purple cabbage soupy stuff through my strainer and into this measuring cup that has a pourable spout. So as I pour it, you can see how really beautiful this color is. It's a gorgeous purple color. It might be hard to see with our little purple fabric here, but I'll hold it up in just a bit. I need to pour slowly. There's no rushing this. I just don't want to get any of this cabbage pulp in there. As I go nice and slow, I'll be good. Now, it looks like it's going to take a while to sieve this out. Let me just pick this up briefly and show you just how beautiful this juice is. It's still going to look kind of dark, but you'll get the picture. Listen, let me finish sieving this, and then we're going to test the juice that we're collecting, this purple cabbage juice. We're going to test it against our 4 ingredients. So hang on just a sec. Whew, that took a while. So I have now strained my ground up purple cabbage soup to remove the small cabbage bits, and now all I have is that pure juice. Now notice the beautiful, beautiful purple color here that we have. A couple things about this. One, if you're doing this experiment at home, be very careful. I changed my background to white, but this is one of my lesser cleanup claws. If this gets dirty or stained, it's okay because this is basically just a white rag. This juice will stain everything. It will stain your hands, it'll stain your clothing, it stains everything. It's delicious, I'm sure, if it was clean, but this stuff will stain, so be very, very careful. And also, there's a smell to this juice. You might remember an experiment we did way, way back in September where we talked about vegetables that had the ability to withstand freezing temperatures and not rot. And we said that those vegetables all contain the element sulfur, which allows them to withstand colds. This is one of those vegetables. Purple cabbage does contain a lot of sulfur, so you're getting sort of a rotten egg or old sneaker or old feet or sock smell. And some people find it alluring, some people do not. I don't mind it, and I don't mind the color either, and that's fine. So listen, let's just set our juice to the side. That juice is going to be what we're going to test for materials against. The first 2 are liquids. So in this glass right now, I'm going to pour a fair bit of lemon juice. Here we go. Lemon juice. That should do it. Good. And in the other glass, I have our good friend white vinegar. Is there anything white vinegar can't do? I don't think so. If I could just get the cap off, I'll be fine. So in this glass, we have some white vinegar. Wonderful. Good. 2 liquids. Now, neither liquid is toxic. Both liquids are used in the kitchen, and that's a fine thing because frankly, they're both delicious. So now what I'm going to do is I'm going to pour an equal amount of our purple cabbage juice into this glass. Let's go with the first one. Let's start with lemon juice. What is our color now? Well, it's lemony looking. It's a delicious lemony color. Now, let's see what happens when I pour my purple cabbage juice into there. Wow. That's a shock. Look at this. Now here's our original color. And after we poured this purple cabbage juice into the lemon juice, look what color it turned. It's now sort of a, my goodness, it's a light kind of a magenta, pinky, cranberry color. Good. Okay. Excellent. So let's put our lemon juice to the side. Now let's address our vinegar. Now, a vinegar right now has no color, even though it has that nice vinegar smell. What's going to happen and how is this going to change color when I pour my purple cabbage juice into it? Wow. Almost the same color it looks as the lemon juice. Look at that. They are pretty identical. Now, to my eye, this color looks a little lighter. This color is a little darker, but they're pretty similar. I mean, my gosh, if you had to look from the top, they look to be about the same. Okay, good. This started out as yellow, and now it's sort of a deep pink. This started out as clear, and now this is a deep pink. Now let's go to our next two substances. One is a solid, and one is a liquid. Hang on. Okay, it's time now to test substances 3 and 4. In this short glass here, I'm going to put 2 tablespoons of our baking soda. It's a white powder. And in this right-hand glass, I only have tall glasses left, I'm going to put a fair amount of the evil fiend called ammonia. Now remember, our cabbage juice is starting out as a deep purple color. Okay, so let's focus on our baking soda right now. Let's bring our glass over, and into that glass I'm going to put 2 heaping teaspoons of this white powder. Baking soda is not toxic in these quantities. I'll leave my spoon in there because I'm sure I will need to stir just a tad bit. Again, we're starting out with a white powder, and into that glass we're pouring our purple cabbage juice. So let's see what happens now. Let's pour our cabbage juice in. I can't tell if there's a color change yet or not. To my eye, it looks like the baking soda and the cabbage juice is more blue. But here, let's see what you think. Here's our baking soda and cabbage juice, and here's our cabbage juice. Cabbage juice is definitely a red-purple color. The baking soda now has turned definitely blue. Sure, there it is, okay? Well, that's interesting. Okay, I can put my baking soda to the side. So again, we're starting with our cabbage juice, and now I'm going to have my glass here. And into this glass, we're going to put the archfiend of science labs everywhere, ammonia. Ammonia is very, very strong. I loathe the smell of this stuff, but it is fascinating because here, for example, if I pour some ammonia into this glass, here we go. As I pour, I'm just going to try to hold my breath because I think the smell of this is just awful. There we go. So I'm starting out with a clear liquid, and into that clear liquid I am pouring my cabbage juice. So here we go. 5, 4, 3, 2, 1, and let's pour. Ooh, wow. There's a shocker. Okay, so it's deep in color, and I'm not sure if you can see it, but we started out as a red purple, and we've gone now to a dark green color. So what is the science behind these 4 substances that we poured our purple cabbage juice into? Hang on. Okay, so let's take a closer look at the chemical nature of our purple cabbage juice. This purple cabbage color is very distinct, it's very bright, it's unmistakable. It just so happens that inside the purple cabbage head, there is a chemical. That chemical is called anthocyanin, and that should be ringing a bell for you. There it is, because we've mentioned anthocyanins previously when we studied cranberries. Back when we studied cranberries, cranberries also contain that same chemical, anthocyanin. And anthocyanins have the ability to change color when they come in contact with other materials. Now, what is in our purple cabbage juice right now? It's just the anthocyanins in that purple cabbage and water. And here we have this lovely purple color. Well, it just so happens that the chemical anthocyanin is used around the world by scientists to determine the pH of other substances. And we mentioned it in our cranberry experiment as well, that pH stands for potential hydrogen. And the pH system is a system of colors. Along with those colors, we have some numbers. So here is an example of the pH color scale that is used to test other things. And notice, look at number 7. Number 7, we have that nice deep purple color, and the word neutral is right there by the number 7. Well, it just so happens that water on the pH scale is a neutral. When water comes in contact with the anthocyanins in the purple cabbage, water does not change the color of those anthocyanins. Water is a pH neutral. So we put that neutral right in the middle of that that number line, that color line. Each color on this color line goes from 1 at the far left to 13 at the far right. And right in the middle is number 7. Number 7 is neutral. And we know that if we're testing anthocyanins against other substances, that anything that turns that neutral color is going to be a pH neutral 7. So it's sort of a starting point. So basically, we tested each of our 4 substances against the anthocyanins in the purple cabbage juice. Now, this container here is, believe it or not, this is the vinegar. Okay. Now, the vinegar started out clear when we poured the anthocyanins in. It turned this sort of deep, deep red cranberry color. Now, if you look again at this color scale for anthocyanins, this turned a color which is about step 3. So we know that the vinegar is not only an acid, but it's a mild to strong acid, and you can smell how strong that vinegar is. Because of the color that this vinegar changed, we know that it has a pH of 3, which is a mild to strong acid. Now let's take another substance that we tested these anthocyanins against, and this would be the lemon juice. Now this lemon juice is also a pinky color, but it's not as deep as the vinegar turned. This is more of like a light pinky color, more maybe like a red grapefruit color. And on the anthocyanin pH color scale, this would be a number 4. This would be a weak acid. So if you compare the colors of our vinegar and our lemon juice is acid, but it's a weaker acid than the stronger acid that's in the white vinegar. And we can tell by looking at that anthocyanin color chart. So again, let's start with our neutral purple color, and let's go to our substance number 3. Now, substance number 3, I started out with 2 heaping teaspoons of baking soda. That baking soda has now turned a distinctive blue color. I added some of these purple anthocyanins to the white baking soda powder, and I've got this blue color. Well, if you look on the chart here, this is going to be to the right-hand side of that anthocyanin color chart. It's going to be a base. And I'm not sure exactly what number this is. It could be number 9, maybe number 10, somewhere around there. But the closest color that we can get to this deep blue, that's what the pH is going to be. It's definitely a base. If it doesn't appear in the chart, just look at the colors to the left and to the right of where you think this might be. And that is approximately what the pH is going to be. So we know that baking soda is a base, but it's probably a weaker base rather than being a strong base. Now, let's go to the last one, probably the strangest one. We started out with a clear liquid called ammonia. And to that ammonia, I added an equal amount of the anthocyanin neutral solution. Once I poured the anthocyanins in, I changed to this bright green color. Now, it's hard to say in the scale exactly where this falls, but I'm going to guess that the pH of ammonia means that it is a base, and a strong base at that. And it's probably somewhere around numbers 11 and 12. If you want to say the pH of ammonia is somewhere around 11.5, you're probably pretty close. So scientists around the world have used the color chart to let people know that when you mix the anthocyanins in the neutral pH solution to anything else, whatever color those things change, like this ammonia here, that's their pH. That's how much potential hydrogen they have, and that'll give you a clue whether they are a neutral, a acid, a base, a mild or strong acid, or mild or strong base. You can get really, really specific with the anthocyanins in purple cabbage. And listen, everybody, I hope you get a chance to try this at home. Please send me your questions. Give me your questions right now in class. We would love to talk about this sort of stuff. Everybody be safe. Please, 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 if you're using a blender, watch yourselves. Make sure you have adult supervision. And kumbaya to all of you. We'll see you next time on McCall Science Enrichment. Take care. Bye-bye.